For our extra credit video project, we decided to look at capacitors and capacitance and how it relates to computer keyboard buttons. This is from chapter 26, pages 777 to 780. A capacitor is two plates that are conductors. They have a potential difference of voltage between them. Capacitance of a capacitor is defined by C equals Q over delta V. And by definition, this is always a positive quantity. The units are 1 farad, and the capacitor must be connected to a battery or other source of charge in order to build charge on its plates. Capacitance of parallel plates is C equals epsilon naught area over D. C and D are indirectly related, therefore when D gets bigger, C gets smaller, and vice versa. If D is smaller, then capacitance increases.
Okay, so our real-world example of a capacitor is a computer keyboard. Each computer key is connected to a capacitor. So when each key is pushed down, the distance between the plates becomes smaller, which therefore increases the capacitance, which also creates more potential difference between the plates. Using the equation delta V equals ED. This potential difference is registered by the computer and the letter shows up on the screen.
Okay, so to better understand what we're talking about, we made a diagram of a keyboard key, and as you can see, the key is connected to a connector, and that connector is connected to a capacitor plate and another capacitor plate at the bottom, and in between those two blue capacitor plates is an insulator, and there's constant current flowing through all the keys in the keyboard, so that's not a problem because we know that capacitors has to be connected to a source of charge in order to gain charge on its plates. And so what happens is when you press the key down when you're typing, the capacitor plates become closer, like we said earlier, and so distance becomes smaller. And this change in capacitance creates a potential difference delta V, and this delta V is registered by the computer, which allows for the letter to show up on the screen.